Okay, so of course, now they have a fraction problem, similar to that that's attached to an x. Okay, say we have 2 over 3x. And then minus 1 equals 5 over 3x. Okay, kind of the same train of thought. When I personally was looking at this problem, if I wanted to move my 1 here, and I got 2 x's, what do I do with these? And I remembered, okay, I can combine them. I wouldn't want to move the larger 1 over here. Knowing that the signs change, now my x is negative. I'm not trying to solve for a negative x. I'm trying to solve for a positive x. There's a step I'm going to show you in 10.2, but I guess until then, if you have the train of thought of keeping your x positive, if I moved, the opposite of a positive 5/3 would be a negative, right? Negative 5/3, negative 5/3. That's going to give me a negative x because it's a larger value. So what I want to do is move my smaller value, my smaller coefficient that's on my x variable, which would be my 2/3. You do not just write 2/3. You have to use the exact same number with the opposite sign, that x being included in, that's the whole number. This is a whole term. Now, whatever you do to one side, you have to do to the other. That cancels here. The only thing I'm left with is a -1 equals, okay, I like these problems. Denominator's the same. You just do the operation in the numerators, right? Keep the denominators. So if I'm going to keep my 3, and I know there's an x attached to it, and then I look, 5 minus 2 is 3. And then I get -1 equals, what does 3 divided by 3 equal? Just 1, right? 3 over 3 is 1. So you would just get 1x. In all honesty, 10.1, anytime you see fractions, there's like maybe 1 or 2 little steps you need to do, and they're either all going to turn into 1 or they're going to go away. They just look ugly, okay? So for this one, it would be a -1. Okay. This problem looks a lot like what we were doing the other day, but of course, there's just like a little bit added. I guess it would be like 9.8 is what I want to say. It's 8x plus 4, and then plus 6x plus 9 equals. So like before that equal sign, we've seen that. We did that at 9.8. You find things, same variable, same exponent, right? Those are alike. These are not. These are not. These are not. These are, and these are. But instead of it just being that expression, which means you don't have an equal sign, now it's an actual equation, and you'll have a left and a right-hand side. You still do the same stuff we did previously, which is why you learned that previously. And so my goal here is I need to solve for x, which means I need x equals something, right? I've got 3 different x's. So at this moment, I'm nowhere near solving for x. I need to figure out what can I do mathematically to like simplify it, and each time figure out what's the next step. Thinking about the end of chapter 9, I saw something similar to this, and I learned that if a term has the exact same variable and the exact same exponent, I can combine it, right? And what I meant by that was, look at your numbers. You would add these together or subtract these. That's why I just say combine, because I'm trying to account for addition and subtraction with that one word, right? So I'm going to combine these numbers, keep and keep. So if you do this, 8 and 6, what is that, 14? These are both positive, so I get a positive 14. Keep and keep. And why I'm saying it twice is keep the variable, keep the exponent. I can combine those because those both just have an x variable with one as exponent. 2. Now if I look right here, I've got a positive 4 and a positive 9. Be sure that you include the sign with the number because that's one whole entire term. If that was negative and you just underline the 4, you're probably going to think it's positive, and then that one little problem like messed up the whole answer, okay? So if you look here, 4 and 9 signs are the same, so we add and we keep. And then I've got this right-hand side over here that I've not messed with yet, so I'm just going to bring it down. So, I mean, good news is I did go from 3x's to 2x's. So, I mean, that's progress, right? I still want to solve for just x equals. So I still need to figure out what's going on in this problem. Looking at my x's, because I'm more concerned with those than anything else, honestly. I know that because I have 1 on both sides of the equal sign, I need to move them together. And the only way you can move something in an equation is to use its inverse. And whatever you do to one side, you have to do the other, right? Like that's pretty much the whole rules. Now, we're just going to switch back to black, y'all. I noticed that if I wanted to move this 13x here, I would have to do the opposite, which is subtraction. So I would do, subtract 13x here, subtract 13x. And I'm kind of like mental math. 14 minus 13, that's a positive 1, right? I would want to move the smaller coefficient, the smaller number attached to my variable. If you did the larger one, you end up with a negative x, and we're not trying to solve for a negative x. So I do the inverse, which is going to get rid of the 13x on my right-hand side, and essentially what it does is it moves it to my left-hand side. Whatever you do right here, you have to do right here. If you don't, you break math, I promise. Now, looking at what I've done, like I'm doing the subtraction on both sides, and then now let me actually compute it. Doing this right here, working from left to right, 14 minus 13 is 1. Keep and keep. It doesn't just go away. It goes away when we do the additive inverse, and it actually does equal 0. But if you do get a 1x, it is just x. Don't let that go away. And then right here, I didn't do anything. That's a positive 13. I've got an equal sign. I think sometimes people even draw a line down it just to remember to keep bringing down their equal sign to kind of maybe keep what's on the left-hand side on the left-hand side and vice versa, okay? And then if I look right here, well, this is the step I'm at now. I've got 13x and then minus 13x. This is the exact same thing, 13, 13x, x. The only difference is it was positive, now it's negative. That means it went away, it canceled. That's the additive inverse. And that's what I wanted. So like, I'm kind of glad it happened out like that, right? And then I've got this plus 5. So I just bring it down. I got 5. I'm gonna scoot up, y'all. Okay, so am I done? No. I can tell you that whatever this x variable is, right, plus a 13 will give you 5, but I still don't know just yet what just x is. X by itself, nothing else. So second verse, same as the first. See what's happening around your x, do the inverse. Whatever you do to one side, you have to do to the other. What's happening around my x? I noticed that there is a 13 being added to my x. The opposite of addition is subtraction. Like they undo each other, right? Like they'll make each other cancel. Whatever you do to one side, you have to do to another, or the other actually, because we just have 2 sides. Now look again at your left-hand side. Didn't do anything to my x. I'm bringing it down. And then I have, okay, $13 in the bank, spent $13 in the bank. You have none dollars in your bank. Equal 5 and then minus 13. So signs are different. You would subtract and keep the sign of the larger, or use your calculator. Just make sure, y'all, when you do this, you don't do 5 and then the little negative sign on the bottom, because even though it is a negative 13, it would just be written like this. Your calculator needs it to be written as 5 minus 13, and it'll actually tell you negative 8. If you do 5 and you try to do like the little bitty baby negative 13, then it'll actually just tell you error because you didn't use the proper operation. This is saying that number's 13. It's not telling the calculator to add or subtract. You would actually need to do 5 plus, and then you open a parenthesis. You do a little 13, and then it'll tell you negative 8. So just be really careful when you do different signs, adding and subtracting, just because if you don't enter it right, like you'll think it's the correct answer because the calculator told you, but just because the calculator says it does not mean that it is correct. Okay, so of course they're gonna do one that is a little crazy. Let's do it. It's really not that bad. Okay, so